Welcome to my channel. So in this video I am going to discuss a numerical problem on Routh Herwitz Criterion. So the numerical problem is the characteristic equation of a system. The characteristic equation of a system is given as follows: s cube plus 3s square plus 7s is equal to 0. Determine the stability of the system. So characteristic equation has been given, that is s cube plus 3s square plus 7s equal to 0, and we have to determine the stability of the system. So in this given question they didn't mention which method that we have to use to determine the stability of the system. So method is not mentioned to determine the stability of the system, but characteristic equation has been given to determine the stability of the system. So whenever characteristic equation is given to determine the stability of the system, then it is better to go for Routh Herwitz Criterion method to determine the stability of the system. So first of all, let us write down the given characteristic equation. So the given characteristic equation is what? S cube plus 3s square plus 7s is equal to 0. Okay, so if you carefully observe, here the highest power of s is what? 3. Okay, order of the system is 3. So highest power of s is 3. So we must check, in order to apply Routh Herwitz criterion, we must check is there any missing term. So here s cube is there, next s to the power of 2 is there, s power 1 is there, s power 0 term. S power 0 means 1. So there should be a constant term here which is missing here. So whenever a characteristic equation is given, if constant term is missing, then you can simply assume some notation for that constant term, and you can rewrite this characteristic equation as, okay, s cube plus 3s square plus 7s plus some constant unknown parameter k is equal to 0. Okay, so you can assume some unknown parameter, some notation. I have assumed here k as the unknown parameter here. So coefficient of k is what? S power 0, that is nothing but 1. So this is our characteristic equation now, that is s cube plus 3s square plus 7s plus k equal to 0. Okay, and now let us draw the Routh Herwitz, Routh array. Let us draw the Routh array table. So for that, first of all, consider the characteristic equation. So how many s power terms are there? S power 3, s power 2, s power 1, and one more is what? S to the power of 0. One more term is s power. So write down in a column starting from highest power of s to lowest power of s. Okay. So starting from highest power of s to lowest power of s, write down s to the power values in a column. So s power 3, s power 2, s power 1, s power 0. After that, draw a line, straight line. Okay. After that, go back to the characteristic equation. You start from the highest power of s, that is here it is s power 3. Consider first two terms, s power 3 and s power 2 term. So what is the coefficient of s power 3? Coefficient of s power 3 is 1. Coefficient of s power 2 is 3. So consider 1 and 3. Write down in the first column here. Okay, 1 and 3 write down in the first column. Now consider next two terms. In the characteristic equation, consider next two terms. So what is the coefficient of s power 1? Coefficient of s power 1 is 7. What is the coefficient of s power 0 is k. Coefficient of s power 0 is k and coefficient of s power 1 is 7. So write down 7 and k in the next column in the Routh array. 7 and k. That's it. No more terms. There are further no more terms are there. So just leave it. So whatever data that was available, you have substituted that in the Routh array table. Okay. Now, so row 1. Row 2. So what should be written in the row 3? Okay. So let us check the terms in the row 3. So first term, unknown term, let us assume x. This is x and this is y. Okay. X and y. Okay. So what is x? So just look above the head of x. What is there? 3 is there. So cross multiply 3 with 7. Okay. 3 into 7. minus cross multiply 1 with k, 1 into k, whole divided by whole divided by 3. Okay, what is it? 3 whole divided by 3. So 3 into 7 you will get 21. So okay, 3 into 7 is nothing but 21 minus 1 into k is k divided by 3. So this is what you must write. X is equal to this. Okay, this is our x. Now let us see what is y. Let us see what is y. Now in order to determine y, there should be terms, another column here, third column should be there. Nothing is there, so let us assume 0. Okay, what is there in third column? In the third column 0 is there. Okay, I am going to erase the other terms which I have written here. I will erase these two. Okay, so in third column nothing is there, so I have written 0. Now what we have to do is to determine y, multiply again this 3 with 0. Okay, multiply 3 with 0, cross multiply. Okay, so multiply 3 with 0. So write down 3 into 0 to determine y. Okay, minus multiply 1 with 0. 1, sorry, my cursor, it is very sensitive. Multiply 1 with 0. Again I couldn't write 1. 1 into 0 whole divided by 3. Okay, whole divided by 3. So what is y? So y is equal to 3 into 0 is 0 minus 1 into 0 is 0. 0 divided by 3, what do you get? Y equal to 0. Y value is what? 0. So x value is what? 21 minus k by 3. Y value is 0. And let us assume this as some AB. The fourth row is, here it is A and this is B. Okay, A and B. I am assuming some notation here. Notations are obvious, you can assume anything. Okay. Now what is A? To determine A, over the head of A, what is there? X is there, isn't it? Above the head of A, X is there. So multiply X with K. Okay, so to determine A, so A is equal to cross multiply. Okay, X, what is X value? 21 minus K by 3, isn't it? So I didn't write there. X into X into K minus cross multiply 3 into y, 3 into y whole divided by x. Okay, whole divided by x. A is equal to, okay, what is A is equal to? X into k minus 3 into y whole divided by x. Now what is x value? 21 minus k. I'm not going to write that. So instead of writing again and again, I will just modify this equation so that it will be easy for you. So x into k minus 3 into y. What is y value? Y value is 0. So I have erased the y. I have substituted 0. So 3 into 0 how much? 0. So 3 into 0 is 0. So I can remove this whole term. Okay. So anything minus 0 is anything, okay, isn't it? So no need to keep it. Now if you observe here x into k by x is there. So x cancel. What is left over? A is equal to k. You will get A is equal to k. So what is there here? Minus 0 is there. I have removed that minus 0. Here minus 0 is there. I didn't write that minus 0. Okay. So here x into k by x will be left over, x cancel, a value will become k. Similarly, if you determine b value, in order to determine b value, there should be another third column should be there. There you substitute 0, again you will get b value as 0. Okay. So now so what is x value? It is 21 minus k. Y value is 0. What is A value? A value is k. So substitute that in this Routh array table. So after substituting those notations whichever I have assumed, those values here in the Routh array, this is our third row, this is our fourth row. Okay. So here I didn't write 0. If you want, you can write 0 here. Okay. So this is it. This is it. Now you just check the first column of Routh array. You just check whether all the terms are positive or not. Okay, they should be positive, then only system will be stable. So first column term should be positive. So 1 is positive. Okay. 3 is also positive. Okay. Next 21 minus k. I don't know the value of k, isn't it? I don't know the value of k. Then I can't say whether the system is stable or not. Again in the fourth row k is there. I don't know the value of k, so I can't say whether the system is positive or not. Stable or not positive. Okay, so it's very hard to say whether the system is stable or not because of these two terms. Okay, if suppose this term is greater than 0, this term is also greater than 0, then I can say that system is a stable system, because if this is greater than 0 and if this is also greater than 0, then here 1 it is already positive, this is also positive, sorry. This is positive. Here I have assumed this term as positive, so this is greater than 0, so it is positive. K is greater than 0 means it is also positive, then the system is said to be stable. Okay, so system will be stable only when all the first column terms are positive in the Routh array table. So let us consider s to the power 1 row, okay, where for the system to be stable, 21 minus k by 3 should be greater than 0. So considering s to the power 1 row, okay, so 21 minus k by 3 must be greater than 0, then only system will be stable. So it is greater than 0, just simplify it, you will get, what do you get? 21 is greater than k, means k is less than 21, okay, you will get k less than 21. Similarly, consider next row, s to the power of 0 row. So there we have already, what did we assume? For the system to be stable, k should be greater than 0. So what is the range of k here? What is the range of k? K is less than 21, greater than 0. So for the system to be stable, the k should lie between 0 and 21. So if this condition is satisfied, if the k value is lying between 0 and 21, then we can say that the given system is a stable system. Okay, that is it. If you have any doubts, if any part of this numerical problem was not clearer to you, you can mention in the comment section. If you are able to follow this, if you are able to understand, just click on the like button and share it to your friends. Thank you for watching this video.